This is Bob Capetto, and this lesson is on absolute value inequalities. So let's take a look at a problem. If I want to look at the absolute value of x minus 2 is less than 5, what's the approach I'm going to use here? I'm going to actually solve it as an equal first to find the cut points. So absolute value of x minus 2 equals 5. You've got to think about, when is that true? When does the absolute value of x minus 2 equals 5? Well, there's two possibilities. X minus 2 could equal 5, or x minus 2 could equal negative 5. Right? The absolute value of negative 5 is 5. So adding 2 here, we get x is 7. Adding 2 here, we get x is negative 3. And you could check that. Plugging it in, 7 minus 2 is 5. Absolute 5 is 5. Check. Plugging in negative 3 minus 2 is negative 5. Absolute value of that is also 5. So those are two cut points. Of course, negative 3 comes first and 7 comes second on a number line. Now you'll notice the sign is less than. That tells me that these will both be open circles. So we'll have an open circle here and an open circle here. And what this does is this divides the number line into 3 pieces, 1, 2, 3 pieces. We're going to test numbers in each interval and determine if it's true or if it's false. Beyond 7, maybe I'll take a look at 8. So is that true? Is the absolute value of x minus 2 less than 5? If I plug in 8, is absolute x minus 2 less than 5? Is absolute 6 less than 5? Is 6 less than 5? That's no. So 8 is no good. I am not going to shade in that interval. Between negative 3 and 7, the obvious number to choose is 0. 0 is always a favorite for us to choose. So again, we look at absolute x minus 2. Is that less than 5? Is absolute 0 minus 2 less than 5? Absolute 0 minus 2, absolute negative 2, is that less than 5? Is 2 less than 5? That's true, that's yes. So I will shade in between here. So this gets shaded. Now beyond negative 3, to the left of negative 3, you could have negative 4, negative 5, negative 6, negative 7, negative 8. Anything you want to choose is fine. Maybe I will choose negative 4. So what is our question again? Absolute x minus 2 is less than 5. Let's plug a negative 4 in there. So absolute negative 4 minus 2 is less than 5. Is that true? Negative 4 minus 2 is negative 6. Absolute negative 6, is that less than 5? Absolute negative 6 is positive 6. Is positive 6 less than 5? No. So all I have is, for this absolute value inequality, is the range of numbers between negative 3 and 7. In interval notation, that would be negative 3, comma 7, round bracket. That would be that. So that's our first example of an absolute value inequality. Let's do a somewhat more challenging one next. This time, I will look at the following. Absolute value of 2x minus 1 is greater than or equal to 9. Let's remember, our process was to solve it as an equal first, and then test and shade accordingly. Okay, if I do it as an equal to find my cut points, absolute 2x minus 1 equals 9, which means 2x minus 1 is 9, or 2x minus 1 is negative 9. 2x minus 1 is 9, or 2x minus 1 is negative 9. If 2x minus 1 is 9, let's add 1 to both sides. 2x is 10. Divide 2, and I get x is 5 as one of my cut points. Okay. Absolute value of 2x minus 1 is 9. 2x minus 1 could be negative 9. Let's add 1 to both sides here. So we get 2x is negative 8. Divide by 2, divide by 2. X is negative 4. You will notice that my symbol here is greater than or equal to, so those will be solid dots. So we lay out the number line. Negative 4 and 5 are the cut points. Negative 4 has to come first numerically. 5 second, they will both be solid dots this time. Solid dot here. Solid dot here. I have 3 intervals to the right, in the middle, and to the left. So let's try a number to the right and see if that's true this time. I'm going to choose 6. 6 is beyond 5. And let's take a look. Is the absolute value of 2x minus 1, is that greater than or equal to 9? Is that a true statement or a false statement? Absolute 2 times 6 minus 1, is that greater or equal 9? Is absolute 12 minus 1 greater or equal 9? Is absolute 11 greater or equal 9? Well, absolute 11 is 11. 11 is greater or equal 9. That's yes. If it's yes, I'm going to shade that way, so everything beyond 5 is going to get shaded. So it goes to infinity. In between negative 4 and 5, an obvious number to choose would be 0. 0 is more than negative 4. 0 is less than 5. So again, we're going to take a look at absolute 2x minus 1 and ask ourselves, is that greater than or equal to 9? Plugging in 0. Absolute 2 times 0 minus 1, is that greater or equal to 9? Absolute 0 minus 1, is that greater or equal 9? Absolute negative 1, is that greater or equal 9? Is 1 greater than or equal to 9? No. So I'm not going to shade in that interval. And then beyond negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, anything you want to use. I think I'll choose negative 8. So again, we want to take a look at absolute 2x minus 1. Is that greater or equal to 9? So we'll plug negative 8 in there. Absolute 2 times negative 8 minus 1. Is that greater or equal to 9? 2 times negative 8, negative 16 minus 1, greater or equal 9. Negative 16 minus 1 is negative 17. Absolute negative 17. Is that greater or equal to 9? Is 17 greater or equal to 9? That's a yes again. So I'm going to shade this interval, which is negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative a million, all the way there. So we've expressed our solution as a shaded number line. So this is 2 separate intervals. The first interval from negative infinity to negative 8, make that a square bracket. Union, my second interval, starting at 5 and going to positive infinity. You never get to the infinities, so whenever you have an infinity, you always have to use a round bracket there. So that's what that one is going to look like. So again, you set it equal, and you test the points in the intervals and see what you have. All right. So let's do another one. What if we have something like this? Absolute value 4x plus 2 is less than or equal to negative 10. Well, if you just follow this blindly, you would say, solve it as an equal. When does absolute 4x plus 2 equal negative 10? So we solve it as an equal, and then we test the numbers in the intervals to see if they're true or false. And you ask yourself, what has to be here for its absolute value to equal negative 10? For its absolute value to equal negative 10? That never happens. So if that's the case, there are no cut points. All right. We have no cut points there. So either everything is true or everything is false. So I have no cut points. I have nothing to test really, or I have no border lines. But let's look to see if it's true at 0. Is it true at 0? Absolute 4x plus 2 less equal negative 10. Let's plug 0 in. 4 times 0 plus 2, is that less equal negative 10? 0 plus 2 less equal negative 10. Absolute 2, is that less equal negative 10? Is 2 less than or equal to negative 10? Is having $2 worse than owing 10? No, that's false. So I don't shade that. So basically I shade nothing. So the answer to this is the empty set. Sometimes we say that. Sometimes we say that. You might say no solution. So this is never true. The absolute value of 4x plus 2 being less than or equal to negative 10 is not going to happen in that circumstance. Let's look at a similar kind of thing. If I want the absolute value of x plus 5 to be greater than negative 1. Well, let's think about this. Let's think about how this behaves. And what can we say? Absolute value of x plus 5 greater than negative 1. Well, the absolute value is always a positive number. Whatever it is, the lowest it could ever be is 0. So again, there are no values where it equals negative 1. When does the absolute value of x plus 5 equal negative 1? When would that happen? Never happen. So again, there's no cut points. But if I test 0 this time, so 0 is the only thing that I have to try, or I could try anything because there's no cut points. We have one interval, it's either everything or nothing. If I want to see if that's true, absolute x plus 5 greater than negative 1, plug in 0. Absolute 0 plus 5 greater than negative 1. Absolute 5 greater than negative 1. 5 greater than negative 1. Yeah, that's true. Yes. So we shade everything. No boundaries. In interval notation, that's minus infinity to plus infinity. Or you could indeed say all real numbers. So it's good to be thinking about what this means. So let's just finish off with one more problem that will have a solution of some kind. Let's just do one more, maybe with some fractions this time. 3x minus 1 is less than or equal to 5. So we're going to solve it as an equal first and say absolute 3x minus 1 equals 5. Well, if that's the case, either 3x minus 1 is 5 or 3x minus 1 is negative 5. So I can add 1 to both sides, add 1 here, add 1 here. I get 3x is 6. Divide 3, and I get x is 2 on this side. Over here, add 1, 3x is negative 4. Divide by 3, x is negative 4/3. And you will notice that our inequality sign was less than or equal to. That will give us solid dots. Let's lay out our number line. Negative 4/3 is here. 2 is here. Solid dots. I now have 3 intervals to test. I can plug numbers in and see what I get. Let's try a number beyond 2, like maybe 4. Is that going to work? Let's see. Absolute 3x minus 1, let's equal 5. Absolute 3 times 4 minus 1, let's equal 5. 12 minus 1, absolute, let's equal 5. Absolute 11, less equal 5. 11, less equal 5. No. So I'm not shading that way. Between negative 4/3 and 2, our favorite number to choose, that's negative, that's positive, is 0. So let's plug in 0, see if that's true. Absolute 3x minus 1, less equal 5. Absolute 3 times 0 minus 1. less equal 5. 0 minus 1 absolute less equal 5. Absolute negative 1 less equal 5. Is 1 less equal 5? Yes, that's true. So I will shade in between here. And beyond negative 4/3, just think about this a little bit. That's negative 1 1/3. So negative 2, negative 3, negative 4, negative 5, negative 6. Pick one. Negative 6 seems perfectly reasonable. You could have picked negative 2. Just make sure you know it's beyond negative 4/3. Again, absolute 3x minus 1 less equal 5. Plug in the negative 6. 3 times negative 6 minus 1 less equal 5. Negative 18 minus 1 less equal 5. Absolute negative 19 less equal 5 is 19 less equal to 5. No. So I'm just going to shade in the middle. What is my answer in interval notation? Square bracket. Negative 4/3, comma 2, comma square bracket. And that will end this lesson.